Hi, in this video we're going to take a look at methods for carrying out a hypothesis test. There are three methods that we know of. The first one is using z-values, the second using the confidence interval, and the third using the p-values. So in the first method we're using the z-values, and in order to carry out hypothesis testing using this method, we're going to find z-value associated with some test statistic. If the z-value is in a critical region, then we reject the null hypothesis. So what does that mean? Well, first of all, we're going to get some parameter based on a test, whatever that test is. Let's say that parameter is a sample mean, x bar. So we're given a sample mean, and then using that sample mean, we can find out an associated test statistic z, which is equal to x minus known population mean divided by standard deviation over root of n, because we are applying the central limit theorem for our calculations over here. So if we do that, we're going to get some test statistic, and we're going to say that if the z value is in the critical region, we're going to reject H0. What does that mean? Well, it means that at 5% significance testing, the critical regions are located on both sides of our normal curve. Dividing both 5% into two symmetrical pieces, we get 2.5% for the left-hand side of the curve and 2.5% for the right-hand side of the curve. And if you analyze actually just this part of the curve, you'd notice that if this critical region is 2.5%, then all the values less than all the values correct in this area are 97.5% of all values. So this has to be associated with z value of plus 1.96. We have to remember that for the leaving certificate, that the test score, the standard score for 95% confidence or 5% significance is plus 1.96. In any case, if we find out that our test score is either in this critical region or this critical region, then we reject the null hypothesis. It means that the test score has to be either less than minus 1.96 or more than plus 1.96. In case that the z value is not in the critical region, we fail to reject the null hypothesis, and that's the claim, the statement we make. So in other words, that means that the z value is going to be between minus 1.96 to plus 1.96. And this is the rule. The rule for hypothesis testing using z values is as follows. If the test statistic is between minus 1.96 and 1.96, we do not reject the null hypothesis. If the test statistics is less than minus 1.96 or more than plus 1.96, we reject the null hypothesis. So how does it look in actual application? Well, in this problem, we have the following statement. It is believed that standard batteries have a mean life of 85 hours with a standard deviation of 12 hours. So this is a statement about the population. A sample of 200 had a mean lifetime of 86.5 hours. We have to carry out a hypothesis test to test the belief that mean life of the batteries is 85 hours at 5% level of significance. So we're going to note first, we're going to note what's my null hypothesis. Well, my null hypothesis is that the mean life of those batteries is 85, and my alternative hypothesis is that the mean lifetime of the battery is not 85 hours, as simple as that. Second, as you remember, we have to state the level of significance. So 5%, which tells me that my the test score has to be either less than minus 1.96 to z greater than 1.96. So any of those options, if the test statistic is less than 1.96 or the test statistic is more than 1.96, we reject the test hypothesis. So let's calculate the test statistic. Z is given by x bar minus mu all that divided by sigma divided by root n. So in this particular problem, x bar is the sample mean, and that's equal to 86.5. Sigma is equal to 12, and n, number of items in the sample, is equal to 200. So that tells me that test statistic z equals to, substituting the values in, 86.5 minus 85, all that divided by 12 divided by root of 200. And after I calculate this quantity, I get that this is equal to 1.77. So this is the value of my test statistic z. Now I'm going to state that z equals to 1.77, which is less than 1.96. And as a result, I can say that the test statistic z is not in the critical region for rejection of the null hypothesis. So as my conclusion, I'm going to state that we do not reject H0, simply because the test statistic is not in the critical region. And the meaning of this is that if we do not reject the null hypothesis, then we can make a claim at 5% level of significance that a mean life of a battery is 85 hours.